Hello everyone, welcome back. So now we are going to solve LeetCode number 23, merge case sorted list. Don't get intimidated by this label which is tagged it as hard, but I find it at most a medium problem. Um, if we have understood what is a priority queue and what is a linked list and how the operations works, this problem gets very easier to solve. Let's understand what the problem is first. You are given an array of k linked lists, lists of linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. Let's say in this example, 145, this is a linked list, and 134, this is another linked list, and 26, this is another linked list. So these are independent linked lists, not connected to each other. And what we need to return is we connect the individual nodes in those linked lists, but that has to be in the ascending order. So that's the premise of the problem. And you can see here for more information, they have given the definition of a individual node in a linked list. So a node looks like it has a value and it has a next, and they have given some helpful constructors to create those linked list nodes. Now that we understood what the problem is, let's think about the solution now. So we are given a list of linked lists 145, 134, 26. I have represented it in a linked list format here. So in order to get to the output, we need to keep getting the minimum value from this one. So now if we just look at it from the top level view, 1 this would be like either of them would give a minimum value. So we can just connect this with 1, and then I need to see what's the next value. Next value will be the remaining other one. So I will connect it with 1. And then the next value here is 4 and 3, but here we have 2. So I need to get 2. But how to continuously keep getting that minimum value? So we know the perfect data structure for that, which is a min heap. Min heap will keep providing the min values in log n time. So now since we know that, how let's add all these lists into the min heap. This is the node from the list 1, and the node from the list 2, and the node from the list 3. So all these represent the head node from each of those linked lists. Now what should we do? We will take the minimum value from this heap. Once we take the minimum value, and we will add it as the next element in the result. So the minimum value here is 1. So it will give me, let's assume that's the list 1. So it will just try to get this 145, this entire thing, like this here, 145. After that, what should we do? So after that, I should try to add this 45 back to the min heap. So I pop this one also out of the min heap. So this will look like this. So what should we do now? I'll take the next element from the current. So I'll mark this as the current one. And I'll take the next element and then I'll add it back to the min heap. So in order to add that back to the min heap, so that will sit here. So that has the value 4. Now let's say the next min element I need to take, and 1 5, but now I'll take the next element here, and then it will return this value, and then I'll mark the next value of the current as this element, list 2. So next element of the current value. So this will be replaced. This entire thing will be replaced by this value. So 134. Now what should I do? I'll take the current and I'll move the current to this node. And then again, I have taken the 1 out of here. So this will be 2 and 4, and this would be deleted. So now what should I do? Again, I need to add the next element from the current back to the list. What's the next element here? 3 and 4. So that is the 3. 3 value will be added. It's already sorted like a min heap. Now again, I'll take the min value from here. Min value here is 2. So that is this from this list, 2 and 6. So once that is there, I will add that to the next element of the current. After that, I'll move the current again. and current dot next, I'll add it back to the min heap. Before that, I need to take out the 2 here, and the next element of the current is 6. I'll add that back to the min heap here. Okay, and we keep repeating this process. Once I add the 6, I'll take the minimum again. So this will be 3, 4. So this 3, 4 will be the minimum here. And if I get this one, I'll have to remove this 3, and this will become 4, and this will become 6, and this will be deleted. After that, again, I'll take the next element of the current, which is 4 here, and I'll have to add it back to this list. Okay, so that will be this 4, like this 3, 4, this is the 4. And then when I try to query the next element, it will return this 4, which is the minimum value, and that will be 4, 5. And I will assign the current dot next as this element, which is 4, 5. Okay, once that is done, I would have removed this one, and it would remain with 4, 6 here. So yeah, now the 4, 5 and current will become 4. So now what will happen? Anybody guess? Okay, so now current is this one, and I'll add the current dot next to the min heap here, and then again I'll query from the min heap. So that would be a 4, which is this 4. So that is just a 4, and then current is equal to current dot next, and current dot next is there's nothing else to add here, that is null. So I won't add anything back to the list here, but there is a 5 and 6. 4 is already taken. Okay, and so the heap looks like this, and 4, 4. There's nothing I'm adding now. So the remaining heap looks like only 2 elements. And then I'll pop the minimum from the heap here again. So that would be just a 5, and I will add that 5. And then this will be deleted from here. So we will be in the min heap, we will be remaining with only 6, and that 6 will be taken out and will be added as the element in this output. So now we have the output arranged this way. So we had created, okay, I forgot to update the current will come here, and we had initiated the values with the dummy variable here, or a dummy head here. So we will return the next value of that dummy, which is this one, as the final output. So this is about it, and the total time it takes is O of n log k, because k, where k is the number of the linked list. So here in this case there were 3 linked lists, and the maximum number of elements that we maintained in the min heaps were this 3, or the k. So that's why it is n log k, better than n log n. Like, we are not maintaining all the nodes at once, we are just maintaining the head of those nodes or head of those linked lists in the min heap, and we were sorting it based on that header value. Okay, let's dive into the code now. So let's break it down, the code, into multiple steps, as we saw in the approach explained on that whiteboard. So here we can start with the initialization of a list node, which is a dummy node, and then we can add the pointers to each of the linked list into a min heap. After that, we need to keep iterating until we have the last node in each of those linked lists, and then keep popping that from the min heap and then adding it to the resultant node. And then we have to return the next node after the dummy node. How do we do that? Let's start here. So I'm initiating a list node called as head, which is a dummy node, and I'm just giving an arbitrary value as 0. This could be anything, doesn't matter. Anyway, I'm going to return the next value after this. And I'm initiating the current pointer and marking it as equal to head. After that, I'm initiating the priority queue or a min heap. Here the criteria is simple. If there are 2 linked lists are given, I'm just checking the value in those 2. So that's the criteria for deciding the minimum element in the min heap. After that, I'm just adding all the linked lists. Okay, in this step, I'm iterating until the min heap is not empty. So let's consider the example here, 145. So current dot next current was dummy, and current dot next I pulled it from the min heap, which would give this list 145. So current dot next became this one pointing to this one, and current is equal to current dot next. So now the current is pointing to this value 1. And then I'm checking if current dot next is not equal to null. Current dot next is 4 here. If that is not equal to null, I'm adding it back to the min heap. And then I'll prompt again. I'll ask min heap, what's the next minimum element? Just give me back the minimum element. So that would give the 1 from here. And I'll make that as current dot next, and current is equal to current dot next. So that would point to this next one. And then again, I'll check if that next value is not null. Then I'll add this 3, 4 back to the min heap, and I'll keep continuing doing the same thing until all the list becomes empty in this min heap. So once all those iterations are done, I'm returning just the head dot next here. So that should give us the optimal solution. The time complexity would be n log k, where n is the number of individual nodes and k is the number of linked lists. So that should be it about this problem. Okay, if you learned anything out of this one, please like this video and share and subscribe. And feel free to comment about any topics that you want me to prioritize. I will make sure to address it. And keep learning. Yeah, until next time, stay curious. See ya.